In this video, we'll look at smaller and smaller objects in a series of steps. We'll start with this oak tree, which is 10 meters tall. Can you see the boy standing underneath? We'll call him Lee, and Lee's height is about 1/10 of the tree's. That makes Lee 1 meter tall. We'll now zoom in using a magnifying power of 10, and that will make Lee's image about the same height as the tree was on the screen before. In this video, we'll continue to find smaller and smaller objects and zoom into them in a series of steps until finally we can see an atom. Now let's find something about 1/10 of Lee's size. The distance between his eyebrows is about right. Let's zoom in to magnify this by 10 so it fills up the screen. Now what's 1/10 of this distance? The width of Lee's iris. That's the coloured part of his eye. His iris is 1/100th of a metre wide. 1/100th of a metre is also called a centimetre. We're going to show you a trick here. 1 on 100 is the same as 1 on 10 squared, because 100 is 10 squared. Scientists often write this as 10 to the negative 2. That's like 10 squared, except that the 2 has a negative in front of it. This negative is telling us that the squaring is on the bottom of the fraction instead of the top. The cool thing is that it's quicker to write it this way, and it gets better. 1 on 1,000 is the same as 1 on 10 cubed, so it can be shortened to 10 to the minus 3. Notice that the 3 corresponds to 3 zeros on the bottom of the fraction. What's 1 over a million? A million's got 6 zeros, so that's 10 to the minus 6. When there are lots more zeros, it gets way quicker to write it this way. We'll show both ways of writing it from now on. Now what's 1/10 of the width of his iris? Hey, did you see the flea that jumped onto Lee's face? Lee's got a flea. Coincidentally, a flea is 1/10 of the width of his iris. That makes it about 1,000th of a metre, or 10 to the negative 3 of a metre. 1,000th of a metre is also called a millimetre. And now the flea is running for cover to Lee's eyebrows. Good move, flea. Let's zoom in. Now we'll flip the angle to show Lee's hair sticking upwards. Guess what's 1/10 of the flea's length? Yep, one of Lee's hairs is 1/10,000th of a metre wide. 4 zeros on the bottom, 10 to the minus 4. This is about the smallest size that the naked human eye can see, and from now on we would need a microscope. If we pan the camera downwards, we can look below Lee's skin and see inside his body. Can you see his blood vessels? If we look inside a blood vessel, we can see that the flowing blood contains red blood cells, and they're about 1/10 of the width of Lee's hair, or 1/100,000th of a metre wide, 10 to the minus 5. They're too small to see without a microscope. Ouch! Here comes an anthrax bacterium, and it's deadly for humans. Luckily, it's rare, and in fact most bacteria are not only not harmful, they're good for you. This one is about 1/10 of the size of a red blood cell, making it 1/1,000,000th of a metre in size, 10 to the negative 6. This length also has its own name, a micrometre. Smaller again is a virus. Most viruses are too small to be seen with a normal microscope, so an electron microscope is needed. A flu virus is 1/10,000,000th of a metre in size. That's 7 zeros on the bottom. 10 to the negative 7. The wavelength of green light is about 5 times the width of this virus. Zooming in another step, we can see that the virus wall, called the envelope, is about 1/10 of the virus width itself, coming in at a staggeringly small 100,000,000th of a metre. That's 10 to the negative 8. The envelope is made out of fats that the virus gets from its host. Yuck! Inside the virus is a strand of DNA, which is its information centre. DNA is a very long but very thin molecule made of billions of atoms joined together. This is the first time we've been able to spot individual atoms. And here comes a sugar molecule, which is a bundle of 45 atoms, about 1/10 of the width of the virus envelope. 1/1000th of a metre. 10 to the minus 9 of a metre. Holy dooly! 1/1000th of a metre is also called a nanometre. Heard of nanotechnology? That's about making things that are about a nanometre big. Even tiny robots that can travel around your bloodstream and fix up your body. At this scale, you can see that the whole world is made of atoms. Atoms to the left of you, atoms to the right of you, above and below. This shows you what a grain of sugar might look like, containing trillions of sugar molecules next to each other. But what's between the molecules? More atoms? Air? Well, it can't be air, because air itself is made of atoms. In between molecules is nothing. Zilch. Zip. Just empty space. Scientists call empty space a vacuum. Going back to our nanometer-sized sugar molecule, we can see that the white atoms are about 1/10 of its size. They're hydrogens, and they're about 1/10 of a nanometer, or 10/10,000,000th of a metre across. 10 to the minus 10. That's crazy small. Now we know how big an atom is. What about the other elements? How big are their atoms? A helium atom is about the same as a hydrogen atom, and all the others are bigger. The biggest is cesium, at a whopping 5 10/10,000,000ths of a metre across. By the way, atoms aren't really coloured like we've shown them here. They're too small even to have colour, because atoms are much smaller even than the wavelength of light. We just gave them different colours so we could tell them apart. So is that it? Are atoms the smallest things in the universe? Not by a long shot. Atoms are made of even smaller particles, called protons, electrons, and neutrons. If we zoom up to a helium atom and look inside it, we find its electrons whizzing around the outside, and its protons and neutrons right in the centre of the atom, called its nucleus. Protons and neutrons are about the same weight as each other, and they're nearly 2,000 times heavier than an electron. That means that most of the mass of an atom is concentrated in its nucleus. We've made the protons and neutrons bigger than they really are here, just so that we can easily see them. But they're really much smaller compared to the overall size of the atom. If you imagine that an atom is as big as a football stadium, then the nucleus would be the size of a pea. In fact, you couldn't even see the protons and neutrons from this distance. We would have to zoom in with a magnification of 10, 5 times, adding another 5 zeros to the bottom of the fraction. That's with 15 zeros on the bottom line. 10 to the negative 15 of a metre. Protons and neutrons are a quadrillionth of a metre wide, also called a femtometre. What's between the electrons and the nucleus? Nothing. A vacuum. That means that an atom is mostly empty space. Since we're made of atoms, so are we. That's enough to do your head in. Anything smaller than a proton or a neutron? You bet. Quarks are a quintillionth of a metre, with 18 zeros on the bottom, also called an attometre. 10 to the negative 18. And neutrinos are a septillionth of a metre, with 24 zeros on the bottom, also called a yoctometre. That's 10 to the negative 24. Did you know that trillions and trillions of neutrinos are passing through your body right now, every second? But don't worry, they're so tiny and light that most miss your atoms completely. That's about as small as it gets. I don't know about you, but I can't imagine stuff that small. We've come a long way since seeing Lee under the tree. Then again, maybe we haven't.